Hello and welcome to Mr. Lamb Science Corner. Today we're doing the element nitrogen. And this one is number 7. So its atomic number is 7. Its atomic weight, which is of course an average, is 14.0067, which means that of the two common isotopes, and there's no way to predict, at least I can't, how many isotopes there are going to be natural, but there happen to be two, and uh, nitrogen 14, 7 protons, 7 neutrons add up to 14, is 99.6% of the total. So you're going to, when you find a bunch of nitrogen, you're going to find mostly nitrogen 14. The other isotope is nitrogen 15, 7 protons, 8 neutrons, 0.4%. Okay? And nitrogen is kind of special in that it forms a triple bond, which we show with 3 dashes. And we'll get into bonding at a later time. But it's what is called a diatomic molecule. Dia meaning 2. So we find 2 atoms of nitrogen combined in natural state, and this triple bond means that it's a pretty strong bond. I mean, if you can imagine, if there's 3 different things holding on to the 2 nitrogens, it's going to be pretty strong, and so it is almost inert. It doesn't count as an inert element because you can make nitrogen compounds, quite obviously, but the gas is sufficiently inert to where one of the major uses of nitrogen gas is basically when I worked at a jerky making plant, they'd put the cans of jerky into a big machine, take out all the air, throw in nitrogen, and so it would be, and then seal it up, and it'd be sealed up with nitrogen in there, and of course nitrogen doesn't support animals or bugs or viruses or bacteria or anything like that. So it makes for a little more stable. It doesn't. Oxygen is very reactive. Nitrogen is not. Discovered by Daniel Rutherford in 1772. Sometimes it's also known as azote. And 78% of the air you breathe is nitrogen. So it's a very common element. It's 6th most common element in the universe. And we'll talk about how they come up with those numbers at a later date. One of the major compounds that is very important is ammonia, which is NH3. So it's 3 hydrogens and 1 nitrogen. You take those triple bonds and you break the nitrogen apart, and you can put in each one of the 3 places you can put a hydrogen. And the men I should say, who discovered how to do this commercially was a man named Fritz Haber, and I didn't check the first name, but a man named Bosch. And so it's known as the Haber-Bosch process. And it turned out to be extremely important in ways that you wouldn't necessarily imagine, because in World War I, in which everybody wanted to go to war. I mean, I've read a couple of books, and it just looks like everybody in Europe said, we haven't had a war for a while, let's go for it. And I'm sorry if I upset people from Europe, but that's kind of what it looked like. But the problem is that Germany only had a year's supply of explosives to conduct the war with, and after that, they were done. So they were kind of hoping for a short war. Well, it didn't work out that way. The first battle, sea battle of World War I took place off the coast of Chile because that's where they got a lot of fertilizer from, and they could turn the fertilizer into explosive because there's not a whole lot of difference between fertilizer and explosive, as unfortunately we found out in Oklahoma City, where they took down that the one federal building and killed a bunch of people. But the reason the fertilizer was there is that there's some islands off the coast of Chile to where a lot of seabirds would roost. And when you have millions of seabirds over thousands to millions of years, that's a lot of poop, quite frankly. And the more proper term for it is guano, so we'll call it that. And there are fertilizer deposits of this guano that is dried out and turned into a rock. And England knew that Germany wanted to get more of this fertilizer so they could turn it into explosives, and they wanted to stop them. So they had a nice sea battle in which Germany lost. So they were up a creek without a paddle until Haber said, wait a minute, I happen to have a way of making ammonia, and from the ammonia we can make fertilizer, and from the fertilizer we can make explosives. And that's what they did. And the war went on long enough for America to get involved in it. And I can't remember how many people, it's something like 20 million people dead for World War I. Sometimes science intrudes significantly. But the Nobel Prize people, in a very controversial move, gave Haber the Nobel Prize in chemistry not long after the end of World War I. Very controversial, but I think the reason they did it is because they knew that yes, you can make explosives out of ammonia, but you can also make fertilizer, and the fertilizer would feed a lot of people. So we wouldn't be able to carry the population that we have on Earth without famine and people dying, and more so than they do now, without the fertilizer. So it definitely has a net positive for that. And so that's what you need to know about nitrogen for now. Thank you very much.